Okay, in this Algebra 1 video, Chapter 1, Lesson 3, we're going to talk about properties of numbers. Our objective is, as the student, I can recognize the properties of, there's 4 properties of equality, the identity properties, the commutative property, and the associative property, because I will be able to justify my work with them. And in other words, there's going to be times when you're going to be asked to sometimes defend how do you know you're able to do what you're able to do. So after a while, you're going to be able to just state it because it seems like common sense, and you may already be able to do that now, but at the same time, there's a common language, almost like a vocabulary moment, so we're stating the reason why. So we want to make sure we can recognize them, especially when other people are justifying their work with them. We want to make sure we understand what they mean. But when in doubt, if you're faced with a situation, an equation, an expression, if you just trust these properties, these are the things that you're allowed to do. So on the topic of identities, I just want to point this out that there's 2 identity properties. There's one identity property of multiplication and an identity property of addition, and they're more obvious than you would think. They're not really that fancy. Same thing goes for a commutative property. There's a commutative property. We can kind of use it for different operations as well. Now on this slide, we've listed out most of the properties that we're going to talk about. We just haven't mentioned commutative or associative just yet. But take a look. The 4 at the bottom, I have them labeled as EQ. Those are your properties of equality. They're essentially telling you what is going to still equal the same thing. And we'll discuss each of those, and I'll give you examples of each of these. So let's work our way through these. Now, anytime you have an identity property, such as the additive identity or the multiplicative identity, identity is essentially saying you're going to do something to it and it's still going to equal itself. So if you look at their example for the additive identity, a plus 0 equals a. In other words, something plus 0 equals itself. But that makes sense to you already. Don't overthink that. That means 5, that's a little sloppy. That means 5 plus 0 will still equal 5. That's all that's saying. And I'm saying additive because it's of addition. So that's the additive identity, if you ever find that happens. So for example, if you're working with an equation, you've seen us cancel things out in the past, and you were technically left with 0 and something canceled when you added and subtracted, sometimes that would be because of the idea of what's about to happen in the additive inverse. But when we're doing the identity, if you're left with plus 0, often that's why we ignore that plus 0 because we don't need it because of the additive identity. So in the multiplicative identity, we're essentially saying, what can you multiply by that will still equal the same thing, and that's going to be 1. It says a times 1 equals a. So an example of that is negative 8 times 1 will still equal negative 8. That's an example of the multiplicative identity, meaning multiply by 1, you still got your number. See what I meant? They're not as hard as they sound. So anytime you have an identity property, it's essentially saying it equals itself, meaning you didn't really accomplish anything. And those are the only 2 identity properties you really need to worry about. And now here's another property that you've already know is common sense, but there's technically a name of it. The multiplicative property of 0, that's essentially saying anything times 0 equals 0. That's all that's saying. So like I said, a lot of these you already know, but we want to make sure we can recognize the names of them. So that's the multiplicative, meaning multiply, property of 0. So an example of that would be 25 times 0 equals 0. Now, let's take a look at the additive inverse and the multiplicative inverse property. These are essentially kind of what we do with wanting to undo things. So let's see. The additive inverse property. That's saying a number, a, plus its opposite, plus negative a, is going to equal 0. So an example of that would be 6 plus negative 6. 6 plus negative 6, well, that equals 0. If you add 2 opposites together, opposite signs is what I mean by that, then they are equal 0. That's all they're saying. They kind of cancel each other out. That's what that's saying. Now, the multiplicative inverse property. That's saying, remember, multiplicative inverse, we said in the past, that was kind of a fancy way of saying reciprocal. So I don't have room for, I guess I have room, reciprocal. What they're saying is something times its reciprocal will always equal 1. So in the example right here, a over b times b over a, those are reciprocals, they're going to equal 1. Now if you're not sure, technically it's because you end up with ab over ab. Well, ab divided by itself equals 1. Now an example with numbers, let's say you had 2 over 3, you multiply that now by its reciprocal, 3 over 2. When you multiply fractions, you go straight across, we end up with 6 over 6. Well, 6 divided by 6, well that equals 1. So even if they were negative, it wouldn't matter. So because if it was like, let's say negative 2/3 times negative 3/2, you would still get negative times negative is a positive. You would still get 1. So that's the multiplicative inverse property. Essentially saying if you take reciprocals, multiply them together, they equal 1. Now, as for the reflexive property, we're going to start talking about the 4 properties of equality. The reflexive property one is so obvious people don't think about it, but it is something you would have to sometimes use when making a logical argument when you include every single step to justify everything you're doing. So they're saying everything's equal to itself. Reflexive, think reflective, like looking at yourself in the mirror. So A equals A. So an example that would be 5 equals 5. And that may seem obvious, but the reflexive property is used very, very often in things like geometry when trying to prove that 2 figures are congruent or whatever. A lot of times they'll share a side, and that shared side will of course be equal because it's the same line. That's getting off track. But essentially the reflexive property is so obvious that a lot of people don't think about it. It's saying it's like a reflection. You're equal to yourself. Now, the symmetric property is something similar to that. Maybe the symmetric property might make you think more of a reflection. Essentially, it's changing the order. So if you're imagining there was a mirror right here between this, A equals B, well, if A equals B, that means B equals A. All they're doing is changing the order. That's it. So, for example, you might see that in the form of an equation. So, and we've done that in class many times. If you may see, like you may have found sometimes we would have said the answer is x equals 5. Well, that means the same thing as if it had said 5 equals x. That's what that's saying. If, let's say, we were solving for x. So you can change that order, flipping them over like that, and it doesn't change anything. It's called the symmetric property of equality. Now, the transitive property, I like to think of the transitive property as if there was a middleman. So in the transitive property, it's almost as if there's like someone who's like the middleman who's handling your transactions. He's the one that you hand something to and he hands it to the next person. So an example that would be if A is equal to B and B is equal to C, in that example, B is the middleman. So because A is equal to B and B is also equal to C, B is the middleman. So what you do is you can cut out the middleman and you can just state right that A is equal to C. You make that connection right away. So it's essentially like having someone in the middle who's handling, like I said, you're like a translator, and then all of a sudden you don't need the translator anymore, you're communicating directly. So A and C are communicating directly, they're equal to each other. So it's just cutting out the middleman. I'll give you an example of that. So an example would be if we said, if x is equal to 4 and 4 is equal to y, therefore we would say x is equal to y. We would cut out the middleman. The 4 would be the middleman in that case. That's an example of using the transitive property. Now, lastly, equality property is going to be the substitution property of equality. Now, this is saying if A equals B, then A may be replaced by B in any expression. So an example of that is if we find out that x equals 5, and then you have an equation over here where there's an x in it, you now can take that x and turn it into a 5. It's almost as if we're kind of plugging in, essentially. So if x is equal to 5, we can replace all x's with a 5. And the same thing would go vice versa. If we wanted to now change that 5 into an x, we could, if they're equal to each other. So that's essentially all that's saying. It's not saying actually solve, it's just saying you can plug in. You can use either or. Alright guys, so an example of what I mean is, take a look at this example at the bottom. Notice I crossed out some of the uses of some of the properties, substitution property. It's silly to recognize when the substitution property is being made in the way that they're doing it. So we're just going to kind of work our way through it, and we see what some of the main properties pop up, we're going to acknowledge them. So they essentially start off with this expression, and their job is to evaluate it, see what it equals. Remember, evaluate is what does it equal. So now you know just from our last video, in your last section on order of operations, you got to start off with grouping symbols, and inside of the grouping symbols, we start with division. So we would start with the 9 divided by 3 right here. Now, it is perfectly fine with me that you just change that to a 3. There's no valid reason necessarily to go so overboard and have to say that is a substitution property. It's just you dividing. Don't overthink it. We're not going to do that. Now, additionally, for the next step, 3 minus 3 is 0. That's where the 0 came from. And so just work your way through it. But now look at this. Here's where I want you to start recognizing some of the identities. Well, notice in that same line, we have 24 times 1. Well, that's just going to give us the 24. And we know that, although I know it's obvious, but be able to recognize, hey, that's a multiplicative identity. Anytime you multiply by 1, it equals itself. Now, in that same line, we're about to do 5 times 0 for the next step. Well, and of course, no anything times 0 is 0, but technically it has a name, and it's called the multiplicative property of 0. And then finally, we're going to have the additive identity property, meaning when you add 0, it doesn't do anything. You're left with yourself. That's the additive identity. It equals yourself. So that's what I mean by recognizing some of these properties. So that's going to be our main goal. Is we describe these main properties, and I just want you to be able to recognize them. What I mostly want you to focus on is how we use the order of operations and just recognize the main properties being used. Let's now talk about the last two properties, the commutative property and the associative property. Alright, so the commutative and associative properties. Now, the commutative and associative properties can be used to simplify expressions. The commutative properties state that the order in which you add or multiply numbers does not change their sum or product. And in other words, 2 plus 3 plus 4 will equal, well, we know that equals 9, but that would give you the same thing as if you had done 4 plus 2 plus 3. If you change the order, it's still going to equal 9. So the commutative property, commute like commuting the work back and forth. To commute means to move, to travel. So if you just change the order of things and they still equal the same thing, you're allowed to do that because of the commutative property. And you can not only do that with addition, you can also do that with multiplication. So for example, 2 times 3, I'll keep using those same numbers, times 4, 2 times 3 is 6, 6 times 4 is 24. That equals 24. Now if you change the order, 3 times 2 times 4, 3 times 2 is 6, 6 times 4 is 24, it still equals the same thing. So if you change the order, meaning you commute, those numbers commute around, they move around, does not change the order, or change the value if you're adding, or if you're just multiplying. And then next we have the associative properties. We have the by the way, we have the commutative property of addition, we have the commutative property of multiplication. We also have the same thing for associative. We have the associative property of addition and associative property of multiplication, excuse me. Now, what they essentially say is that the way you group 3 or more numbers when adding or multiplying does not change their sum or product. So for example, 2 plus 3 plus 4. Now, if you suddenly decide to group these two, it's not going to change the value of what it's going to give you. That's what they're saying. It's still going to equal, in this case, 9. Now, even if you had said, let's group these two, it's still going to equal 9. So the associative property, associate, like as in to associate with someone, to have relations or to communicate with someone, who are you paired with, that's what this is kind of saying, the associative property. That's where its name comes from. Now, the same thing goes for multiplication. If we have 2 times 3 times 4, you can group the 2 and the 3 together, okay, and it's still going to equal 24. Or if you group the 3 and the 4 together, it's still going to equal 24. It doesn't matter. So the order you group them in, the way you group them, if all you're doing is multiplying, doesn't change the value. Same thing goes for adding. Alright, so let's take a look at these two examples below and just kind of practice recognizing some of the properties in action. So in the first example, example 1, it says evaluate 6 times 2 times 3 times 5 using properties of numbers. Now name the property used in each step. So we start off just by listing them, okay? And now some of you might prefer to multiply numbers in a certain order. So if you were to do them in a certain order, so let's say you would rather, instead of doing 6 times 2, you would rather do 6 times 3. By changing the order like that, if we're just changing the order of everything, we move things around, they travel, they commuted, it's the commutative property. You then, a lot of people sometimes multiply these in pieces, like they would say, maybe multiply these two together, then multiply these two together, so, and then multiply them together. But that idea of grouping those together to multiply those first, that's going to be the associative property, by doing those first. And then for the last two steps, we're just multiplying to get the final answer of 180. Now, I agree that the way that this was set up, the steps these went through, were almost a little bit of preference. So not everyone would have answered these necessarily the exact same way, and that's okay. But what I want you to focus on is just necessarily what these properties look like when they're being used. Now, the example to the bottom right does exactly the same thing. It starts off with a question. This is an addition problem, and so it starts by changing the order for this line right here, and then after that, so that's a commutative property because they commuted, they traveled. And then the second one is where we're grouping them together to add things that go together. For example, it's a lot easier to add 8.2 and 1.8 because they equal a whole number, they equal 10. It would be tougher if we did the 8.2 plus 2.5. We would have to deal with decimals. So sometimes it's very strategically smart in order to use the commutative property and then the associative property to group things together in a certain way. So I wanted you to see some examples of using the commutative and associative property with these. But at the same time, once again, I know these are the types of things we've already been talking about before now, where we've been discussing them, but we haven't been necessarily naming them this. But I wanted you to realize there are names for these properties that we sometimes take for granted as if they're common sense. If they feel like common sense to you, that's good news. That means you understand how they work. Now let's just practice being able to recognize them. That's what this section's all about.